Hello everybody and welcome back, and right now let us start off first by coding a server connection with the socket library. Now before we actually begin, let me just tell you a few things. Basically things will break from time to time, so don't let that upset you or discourage you from actually finishing this code. At the end it should all work properly, but if you have some problems, make sure to check out on the internet. Basically some of the functions may be outdated on your Python version or something like that, and they may have a new name or a different name or something like that. Basically I will code right here in Python 2. But I will also sometimes use the syntax for Python 3 so that you actually can use this on both Pythons. But most likely some of the tools right here will be from Python 2, or basically libraries. So right now let us get started with our server coding. So what we want to do is, as I said in the previous video, we want to create a connection with the socket library. So let us do that. So first of all, let us make a directory for reverse shell. So let us call it reverse. And we have our directory right here, so we don't mix these Python basic programs with our reverse shell. So let's change our directory to the reverse shell, and let's nano our server. So we will start off with coding the server. So server.py. We should start off as in every previous video with the path to the actual Python. So hashtag exclamation mark then slash user share Python. This is something that you need to have included in all of your Python codes. And after that, we want to import the library that we will use, which is called socket library. So import socket. Right now, what we will do is we will basically create a simple connection with our server. So let us do that. We will use first of all, what we have to do is basically we have to declare our socket. So our socket will be IPv4 and it will run over TCP. Now the function that specifies that is specified like this. So we will type here s equals socket.socket and then open parentheses, parentheses, socket.af_inet, which basically stands for IPv4 address. So we want to make a server that will listen on IPv4 address, and then comma socket.sock_stream, which specifies that we want to have a TCP connection between our server and our client. So this is the beginning code of actually defining the socket itself, the socket descriptor, which will be written into the memory and actually accepting the connections after that. So this is how you do that in Python. It is very similar in other programs as well. So this af_inet and sock_stream is something that you probably saw if you coded some TCP servers in other programming languages as well. So after we do that, what we want to do is we want to set some of the options for our socket. So just follow up with me with s.set sockopt. I believe that is how we specify this function. And then what we want to type is socket.sol_socket, comma socket.so reuse addr, comma 1. So this is just some of the basic socket options. This socket.so_reuse addr basically allows a process to connect to a port, our local hosting port, even while it is in time wait. So it will make more sense later, but let us see our picture and what we have to run next in order to create our server. So we set up our socket with this command right here. We set up some of the options, so we specified our socket. Now what we have to do is actually bind the socket itself with, or basically bind the port that we will listen on, and also bind the IP address. So we have to specify the IP address that we want to listen on. Now in the process of actually creating this, we want to specify a localhost IP address, which is basically same for everyone, which is 127.0.0.1. since we want to be able to run both client and both server from our Kali Linux machine. Once we actually notice that everything is running smooth and good and this program doesn't break, then we can switch the IP address to our local IP address or port forwarded, or basically a local IP address or of the ngrok IP address if we run the attack over the internet. But if you run the attack on localhost, you want to have your local IP address in the s.bind function that we will write right now, and you can specify any port you want as long as it isn't used currently by the system. So don't specify a port like 80 or 22 or something like that. If you have SSH open, specify some random high port. So let us write the function which is bind, so s.bind. Now make sure that whatever you called your socket right here, which in my case I only called s, make sure to type it as well in other functions. So for example, if I call this sock, I would have to write here as well sock.bind and sock.set sock options. So make sure to follow up with that, so don't actually name something different and then use a different name later on. You have to use the same socket name for the entire program. So let us bind our port and our host. We do that with open double parentheses, so open two parentheses, then type here your local host IP address, which is 127.0.0.1, close the apostrophe, and we can see this is actually a string, so it is under two double quotes, and right now we want to specify a comma, and after the comma we specify the port that we want to listen on, which in my case I will just specify 54321. Doesn't even matter as long as the port isn't used by anything. So close double parentheses, and right now we were successfully specified our IP address, which is our local host IP address, and our port that we will listen on. As I said before, this is something that you will change after we finish the entire program, so you can use it on any other machine. Right now, as we can see right here, the next thing we want to specify is the listening. We want to listen for the incoming connections, so you can do that with s.listen, and let's specify one in the parentheses. Basically means it will listen for one connections. If you specify two, it will listen for two connections. Let's specify 5 connections, so it listens for 5 connections. After we do that, let us actually accept the connection itself, and if you see right here, the accept, it doesn't show what it has to take, but basically what it has to take is the target and the IP address. The target is a sock, basically the file descriptor that it will store in memory, and the IP is the IP address of the target machine. So let us name it something like this. So target, comma IP equals s.accept, and you open and close the parentheses. Now in the accept function you do not have to specify anything in the parentheses. You can basically just specify the parentheses open and closed, which means it only uses function without the actual input in that function. So with this we get the file socket descriptor for our target, and it stores it, and we also get the IP address of our target, which we will use in order to actually print out from which IP address we received the connection. Right now we can save this program, as this is the most simple use of server. After we accept the connection, we can print, just so we can see that it does work, so print for example target connected, then exclamation mark. We put that in the double quotes, and we can then close the connection, so s.close, and this is our server finished. So let's actually try to see if we can receive a connection with this program. It might break. I didn't double check this before, or I didn't code it before, so we will fix anything that actually breaks in our coding process. So one thing I want to specify right here is when it starts to listen, I want to print listening for incoming connections. So we want to print once it listens, and then we will try to connect with our other terminal, and if it connects successfully, it will print target connected, and then it will close the connection. So let us save this, so Control O, enter, and then Control X. And then we want to chmod this so it can actually be an executable. And we want to run this. Permission denied. Why is the permission denied? Bad interpreter. So let's see. User share Python. Okay. Let me just see what are other programs. So cat Python 3. User, oh, yeah, it's user bin Python. It's not user share Python, pardon me. So we need to specify, what was the directory name? Reverse. We want to specify actually user bin Python. It's not user share. So change this. Not really sure why I typed user share, probably because I was talking about Metasploit, and then Metasploit is located in user share. So just change this to user/bin/python. Save this, exit, and now chmod it. We already did chmod, so we can actually run the server right now. As we can see, it just prints out right here, listening for incoming connections, so we know it performed all of those functions correctly, and now it is listening for an incoming connection. Now we can specify an incoming connection with a different terminal, so let's open up a new window. Let's actually enlarge this a little bit, so something like this. And right now, let us try to netcat on our local host. Not really sure if that's impossible, it should be. So nc, what is the 54321? And here we can see that we successfully connected to our program. As we can see, it said target connected. So we successfully connected to it and it closed the connection. So our server works, it can accept the connection and it will print out target connected once someone connects to our server. So good, now that works. So that is the most simple coding of the server. We will fix that code a little bit, add something here and there, and then we will continue with our client afterwards. Now in the next section, in the next video, we will actually code the simple version of our reverse shell of our client, or basically our payload that we will deliver, which will successfully connect to our server.py, so we can run two Python programs and see if they interact well with each other. So that would be about it for this tutorial. I hope I see you in the next one, and take care. Bye.